All right, everybody. Welcome to How to Photograph a Lunar Eclipse, our one-night AAA class. And thanks, everybody, for coming. I'm going to share my screen here. And coming up on March 14th, in the early morning hours, is a total lunar eclipse that we'll be able to see here in New York City. The actual eclipse will be visible in North America, South America, and Greenland. And if you could see the moon, you'll be able to see the eclipse. So in any of those areas. And so this will help you prepare a little bit visually, but mostly if you're interested in photographing the eclipse. A couple of weeks ago, I thought, well, maybe it might be a good idea to have a short class and just go over some of the basic principles on how to photograph an eclipse in case you've never done it or never seen one. This would be a good chance to do that. But my name is Stan Honda, and I'm part of the AAA Astrophotography Group. I help coordinate the astrophotography group email and also our Gateway remote telescope. And so if you're interested in any of those, go on the AAA.org website and you could check out definitely the Gateway telescope. So let me talk about a few ways that you could follow us. You could follow the AAA on two Instagram accounts, AAA NY _ astrophotography, and Chirago Preti posts a lot of the photographs that our group takes, both through telescopes and with digital cameras, wide angle lenses. And also AAA.org is the club Instagram. So you could check out both of those. If you have any interesting astro photos, tag AAA NY _ astrophotography, and Chirag will try to make sure that he shares your picture on the club Instagram. And of course, you could check out AAA.org, the club website, for all the activities that we do. And you could also follow AAA on Facebook. And we also have a YouTube channel, and we'll be posting this class recording to the YouTube channel. Okay, so what is an eclipse? So a lunar eclipse is when the moon enters the Earth's shadow, the shadow created by the Earth from the sunlight. And a total eclipse is when the entire moon enters the shadow, which is called, the deeper part of the shadow is called the umbra. There's sort of a fainter shadow that surrounds the umbra called the penumbra. And as the moon enters the penumbra, technically the eclipse has started. It's difficult to see unless you're in a pretty dark area, and even then, it's kind of hard to see the effect on the moon. But as it enters the umbra, that's something you could see with your naked eye. The great thing about an eclipse, both a lunar eclipse and a solar eclipse, you don't need any special equipment or viewing devices. You could see both of them with your naked eye. The moon, you could see perfectly well without any aid. Partial solar eclipse, you would need the solar eclipse glasses or an approved filter just to take a look at the partial eclipse. But the good thing about this total eclipse, no special filters needed, and long as you could see the moon, you could see the eclipse. So the moon's orbit around the Earth is tilted at about 5 degrees to the Earth, so the moon itself doesn't enter the umbra every month, which would be kind of amazing to see an eclipse every month. So the moon and the umbra only line up every once in a while. Usually, there's usually 2, sometimes 3 lunar eclipses in every year. This year there happens to be 2, and there are 2 total lunar eclipses. The second one is in September, but it's visible on the opposite side of the Earth. It'll be daytime here when the eclipse is happening. So next Friday morning will be the total lunar eclipse that we'll be able to see here from New York City. So let me show you this website called timeanddate.com. It's a great website. There's a few others that have eclipse information. I go to timeanddate.com. It's pretty easy to use, and you just search for the total lunar eclipse on March 14th, 2025, and it'll give you a ton of information. It opens on this map here that basically shows you globally where the eclipse will be visible. The darker pink region is where the entire eclipse will be visible. And as you go out from this central region, some of the partial eclipse may or may not be visible, but I think out to this band, the whole total eclipse will be visible. So as you can see, it covers everything from the North Pole to the South Pole, North America, Greenland, South America, Antarctica. So if you're anywhere within this area on this hemisphere, you'll be able to see the lunar eclipse as long as it's clear. You could zoom in on this map, and you get some pretty good detail. And the reason you do this is you could find out where you are going to be, whether it's in New York or any other place. You can click on a spot, and it will give you incredibly detailed information about the eclipse itself. It'll show you the coordinates that you're at. It'll show you the durational totality, when each phase of the eclipse begins and ends. If you click on the coordinates, it'll take you to a page that kind of summarizes a lot of the information in a pretty easy to understand, easy to view format. So this is technically it starts on the 13th, just before midnight, and then but most of it, the visible part that we'll see is the early morning hours of the 14th. It'll give you this animation, which I'll run in a minute or so, and it gives you this great chart that shows stuff about the when the phases begin, when they end. So you don't really need to pay attention to the penumbral eclipse part, because that's hardly visible. So 1:09 a.m. on March 14th. So if you're a night owl, if you go to bed really late, then you don't need to go to bed at all. You might need to set an alarm if you go to sleep early. So at 1:09 a.m. on March 14th, the partial eclipse begins. The total eclipse begins at 2:26. So that's when the moon has gone all the way into the umbra, into the shadow of the Earth. And totality is fairly long. It looks like it's an hour and 5 minutes. So 2:58 is sort of the maximum eclipse, just the middle part of the eclipse. And the total eclipse ends at 3:31, so an hour and 5 minutes. And it'd be amazing if we had an hour and 5 minutes of a solar eclipse. It would be a lot easier to photograph. So when the lunar eclipse is happening, you don't really need to rush around too much in terms of getting photos. As you can see, the eclipse the total part will last quite a while, and give you plenty of opportunities for different kinds of pictures. And the partial eclipse will end at 4:47 a.m., just about an hour or so before, hour and a half before sunrise. The chart here will also give you information about where the eclipse will be in the sky. So it'll give you direction, the compass direction, but also the altitude, how high the moon will be in the sky when the eclipse is happening. So the partial eclipse will start at a compass setting of 182, which is basically south, and at an altitude of 51.8 degrees above the horizon. So 45 degrees is halfway up if you're looking up into the sky. 90 degrees is straight up, the zenith. So 45 is about halfway up. So a little bit above halfway up into the sky. So relatively high in the sky. And so as long as you're in an area where there aren't any really tall buildings, and that you could see mostly to the south or the southwest, you'll be able to see the eclipse, weather permitting, of course, and as long as there aren't any clouds in the way. The good thing about this eclipse is that it will start, the partial eclipse will start at a point in the sky, and the moon will descend. And so you'll be able to sort of predict where it will be because it'll just be descending as it's essentially setting. It'll reach uh, its peak altitude when it's at about 180 degrees, the southernmost point. And then as the eclipse progresses, the moon itself will descend. And it'll, at the maximum eclipse, it's about 44 degrees above the horizon, so about halfway up. And then when the partial eclipse finally ends, it'll be 26.7 degrees above the horizon. So not it's still not still relatively high, but much lower than it was at the beginning. Any questions about the timing and the direction and the altitude? So let me run this animation, which is really pretty interesting. They do this both for solar and lunar eclipses, so it gives you an idea of what you actually might see. So they start with the penumbra shadow coming over the moon, and again, you won't see a whole lot, maybe a slight dimming of the moon. So now the umbra begins, and so that's where you'll see this bite out of the moon as the umbra starts to cover the moon. It'll start in the lower left-hand corner of the moon as we're watching it in the sky, go diagonally up to the upper right-hand side. And the animation will also give you the altitude and the direction as the eclipse progresses. So once it's fully into the umbra, now it's the total phase. The moon, because the Earth's atmosphere, as the sun comes through the Earth's atmosphere, the blue end of the spectrum is deflected out, and a lot of the red end of the spectrum from the sunlight gets through the atmosphere and creates the umbra. And so it's mostly reddish light that's falling onto the moon. So that's why the moon becomes very red during a total eclipse. And the brightness and the redness can vary dramatically during eclipses. A lot of it depends on what's in the atmosphere around you. It could look actually fairly bright red, almost oranges, or it could often look very dark, almost a brownish orange, depending on if there's a lot of particles in the atmosphere, if it's a clear night, or if there are any kind of clouds, haze, things like that. So that can actually affect the color of the moon as we're seeing it during the total phase. So it passes through. It often doesn't pass directly through the center of the umbra, and here it's at one side, and then as the moon is going in its orbit, now it's leaving the umbra, and you'll start to see basically the opposite end of the partial eclipse. And so the moon will get brighter from the upper left-hand corner, and the brightness will increase diagonally to the lower right-hand corner. So this will give you a general idea of how the eclipse itself will rest in the sky. I'm not a real expert on eclipses, so I can't really answer too many questions about eclipses. But let's see. I think looks like there might be one. Okay, and when we're going to get to all of those, all of your questions shortly. So let's see. So we covered that. So what will the eclipse actually look like from a photographic point of view? I put together this composite from an eclipse in 2015 that was visible here in New York City. And as the animation showed you, the initial partial eclipse, you sort of see this bite out of the moon, the shadow coming across the face of the moon. And then it becomes, during the total phase, it becomes very reddish, orangish looking in color. And then it will begin to exit the shadow, and you'll see more and more in the moon during this phase. So that's essentially what you'll see in terms of visually watching it. So what kind of the kind of picture you want and the kind of equipment, that's the kind of things that you'll be able to answer. So the kind of equipment that you'll need, you really don't need anything fancy. Basically, you need a camera, a tripod, uh, uh, and a lens of it, really of any focal length. And what I also recommend is a remote shutter release, something that you could trip the shutter and uh, not be pressing the shutter button on the camera. So there's a lot of uh, remote shutter releases that you could buy at places like Adorama and B&H. Oftentimes, there could be apps on your cell phone that could match up with your phone, and you could basically use your phone to trip the shutter release. Anything that where you could be away from your camera and trip to shutter release, because during the total phase, the exposures can get fairly long, and so you don't want to be moving the camera as you're trying to take a picture. And so the having a remote release will decrease the chances of any kind of camera movement, camera blurring, and so that you'll have a pretty sharp picture. And so there's generally two different kinds of pictures that you could take. There's depending on the kind of lenses, there's sort of almost an infinite number, but two general ways, and they're basically telephoto or wide angle type images. So a telephoto, you have a pretty giant moon in the picture. Chirag Apreti took this at the eclipse in 2022 in early November. That was from New York City. That total eclipse, we were pretty fortunate because the moon itself was fairly low on the horizon during totality. So uh, people like Chirag could get a pretty decent picture of the moon with landscape elements like buildings here. And he used a 600 millimeter lens to get a pretty big moon in the picture, but also get a lot of detail on uh, the skyscrapers in this photo. Andrew Warner took this picture from Brooklyn, and he used a Sony camera mounted on a small Red Cat telescope, which is essentially a telescopes and telephoto lenses are essentially the same optical device. And so his Red Cat 51 is 250 millimeter focal length. So anyway, between a 200 and 300 millimeter lens on a full frame camera, and he was tracking. So he's able to do a fairly long exposure. I like this picture because uh, where the moon isn't huge in the picture, you kind of get a sense of it floating in space. There's stars in this picture. I hope you could see the stars through the through the Zoom broadcast. And so you kind of get the idea of the moon actually being out in space and being surrounded by stars. So there's sort of a variety within focal lengths that you could use also to take photos. One thing I do recommend, there's a couple of approaches you could use with telephoto lenses. So this is kind of the setup that I use for the telephoto picture. And if you've got a pretty long focal length telephoto, for example, in between 400 and 600 millimeters, it's a good idea to try to have a mount where you can actually follow the moon easily. And if you have a pretty big telescope tracking mount, that would work. If you didn't want to set that up, what I recommend and what really works for me, I've used this geared head for many solar and lunar eclipses. Benro and there's a couple other companies that make three-way geared heads like this. It's great for long telephoto because as you turn those knobs, it moves the mount in whichever axis you want in very slow increments. And so which is perfect for an eclipse because if you're needing to follow the moon as it's going across the sky, it's not going very fast, and it helps if you can move your camera lens in small increments because then you could keep up with the moon and not have to uh, and not worry about it going too far in front or in back of the moon. For a very long telephoto lens, a ball head is generally not such a great idea because you don't have that much control over once you kind of loosen the ball, you often don't have much control over the lens, and you have to recenter it somehow. At least the geared head is great because, especially in a telephoto lens, the moon will start out on the say the left-hand side of your frame. It will slowly go across to the right-hand side, and then you just need to move it back to the left-hand side to continue taking pictures. And with the ball head, that's fairly easy to do. Any questions about the telephoto end of it? I think I see one chat. So Alberto, your question was even a timer. Now, what is your question about that?
I understand this was about as an alternative to a remote, not to have the camera move.
Let's see. Are you talking about maybe using a self-timer?
Yes.
Okay, yeah, that's a good alternative, using the self-timer on your camera, and that oftentimes you could set it, and that you could as you're going along throughout the night, you could just use the self-timer if you don't have the remote remote shutter release. That would work pretty well. And then I would probably, oftentimes in the camera, you could set it for different durations, and probably 3 to 4 or 5 second duration would probably be good, because if you need to press the shutter release to start the self-timer, you're introducing some vibrations into your camera lens combination. So if you have it at about 5 seconds, that'll be enough time for the vibrations to settle down, and then your camera will be pretty steady once it takes the picture.
Thanks.
Okay. So the other kind of picture you could take is a more wider picture with a wide angle, or a George Priotiasa in the 2022 eclipse. He used a 50mm lens on his Sony A7, and that worked out pretty good. A 50mm is actually a good focal length on a full frame camera for things like the moon and the sun, because you get a sense of the landscape around it, and yet the moon is still relatively a good size in the image itself. So he did a whole series of pictures for this shot, and then assembled them after the eclipse. He told me this was he used intervals of 2 minutes between each of the moons in this picture, and then assembled that. There was a group of us in Long Island City at the Gateway Park that was looking out onto the. It has a spectacular view of Manhattan, so it was a good angle to get this particular eclipse. Yeah, and the so as you can see, we were pretty lucky because as it entered totality, it was relatively low on the horizon. The top of the Empire State Building from this angle is about 9 degrees in terms of how high above the horizon. So this was a great combination. I think the relatively low moon and the New York City skyline. Unfortunately, the eclipse on next Friday, the totality would be pretty high in the sky. So pictures with the skyline might be tough unless you're pretty close to some fairly tall buildings, and then that way, as you're looking up, you might get the moon and the buildings in the same photo. And this is something that I photographed in 2014 in New Mexico at the Very Large Array. This was again in the middle of the night, or well, I think starting at about 11:30 and then going into the next morning. I went with a friend of mine, and we drove down to the Very Large Array and set up near one of the antennas. And the reason I'm showing this is that the eclipse on Friday will generally take this shape as it goes through the sky. The partial phase will start higher up in the sky, but generally it'll make this sort of this descending pattern, and from about as we saw on that graph or the chart from time and date, from about 52 degrees down to about 26, 27 degrees up in the sky. So this will be the general path that it takes, and that might help you with any kind of planning that you're going to do for the eclipse. So let's get to some of the actual details about the settings and all that. Focusing, I'll talk about focusing and exposure setting. And so we're doing night photography, night sky photography. Any of you who have taken the night sky photography classes that we've done know that focusing and exposure settings are two of the more difficult ones. And for an eclipse, if you've never shot an eclipse before, it's the same principles. You basically have to use all manual settings for both the focusing and the exposure setting. So for focusing, you can probably use autofocus to focus on them, but then you have to disable the autofocus as you're going to be shooting the picture. Or you could start on manual focus, manually focusing on the moon, and then that way your camera lens will always be on manual focus. The reason you do this is because if you're used to focusing by pressing the shutter release lightly on your camera, unless that focus point is pointed on the moon all the time, then you're going to get an out of focus picture. If you compose and your focus point is out in the middle of black space, it's going to be trying to focus on that, which is never works out very well, and you might get a lot of out of focus moons. But if you focus on the moon, either disable the autofocus at that point or switch to manual focus, your focus is essentially locked on that distance, almost infinity. So that way your focus won't slip as you're taking pictures. A good tip for doing some focusing with mirrorless cameras, you'll always have the live view. With the DSLRs, if you could use live view, you could zoom into the moon, manually focus, and then you either switch off the live view or you could keep it on to help you compose. With a telephoto zoom, if you're using a long telephoto zoom, it's best to focus on the moon at the focal length that you're going to be using, because if you focus on using a different focal length, if you go to say the longer focal length to take your picture, the focus might change as you're zooming. That often happens, and so you definitely want to be focusing at the focal length that you're using. Similar with the wide angle, choose the focal length. If you're using a wide angle zoom, choose the focal length that you're going to be shooting at, focus on that, and then switch it to manual or disable the autofocus. With a wide angle, with a telephoto, you can definitely focus on the moon. That'll be, since that's your subject, that'll be an easy thing to do. Definitely with the longer telephotos, like 400, 500, 600 millimeters, you could probably use autofocus to get your initial focus, and then switch the autofocus off, go to manual focus, and then you'll be locked in there. With a wide angle lens, you could often focus on the moon. If that doesn't really work, you could focus on a distant building, something way on the horizon, a bright light on the horizon, and you'll have enough depth of field where it should carry. And you could take with both of the different kinds of lenses, definitely take a bunch of test pictures, zoom into the preview picture that you shot, make sure that everything's in focus before you continue. A good tip is to tape down the focusing ring, whether you've used manual focusing or autofocusing. That'll prevent it from shifting around during the night as you're photographing the eclipse. And also check the focus about every 20 minutes or 30 minutes if you're going to be shooting from the start of the partial to the end of the partial. Only because sometimes things just slip, and it doesn't take much to be slightly out of focus for something like an eclipse, and you want to make sure that all your pictures are in focus and sharp. So any questions about focusing? And this is something you could also practice. I'll talk in a little bit about going out and actually practice, being able to practice shooting in eclipse. But you can also do a lot of this on the moon now, or any kind of other subject, the distant buildings, things like that. You could try the autofocus, try the manual focus, and see what works for you.
Hey,
So no question. Oh, sorry. Go ahead.
How much interval do you recommend if you want to take like a multiple frames?
I'm sorry. How much? What?
Interval.
Okay, I'll talk about that toward the end, about doing the time-lapse sequences. I'll definitely answer that question.
Okay, thank you.
I want to concentrate on the basic stuff first, and then we'll go to the doing the composites. Let's see. So if there's nothing more about focusing, I'll go to the exposure setting. So again, it's best to be in manual. Don't use any kind of auto or program setting, because the camera will try to compensate for the large amount of black sky in your picture, and you'll get a nice overexposed moon. And you won't have any real control over the way the moon looks. So use the manual exposure mode in your camera. And the next two suggestions are sort of related with the partial phases. If you're using the light meter to actually determine the exposure, you need to essentially overexpose by about 1 f-stop or more to maintain that bright look of the moon. I suggest, and pretty much every digital camera has a spot meter setting. Usually if you go into the metering mode, there'll be which many companies call it matrix metering, which is it measures the entire the entire frame. There's center weighted, which kind of measures a big circle in the center, and the influence gets less and less as it goes out from that circle. And then spot meter measures a very small spot, usually right in the center. It's usually the focus spot. So if you look through your viewfinder, you see the focus spot, which is often a small square or rectangle. That's the area that the spot meter will be measuring. And so it measures a very fine area, which is perfect for something like if you're going to use a telephoto lens, and you could put that spot on the moon, then you'll be able to get an accurate measurement of the light on the moon. And again, if you use the light meter scale and you put it at the 0 setting, in other words, a so-called good exposure, you'll probably get a grayish looking moon, and it won't look like it does during a full moon. And that's why you essentially put it at the +1 setting, or even 1 1/3, 1 2/3, just to make it look bright. When you look at the picture on the back of your camera, it's going to look brighter than it is on your computer screen. So keep that in mind. It's just like a lot of the night sky pictures, night sky landscapes that we could take. When you look at it on the back of the camera, it's very deceiving. It's brighter than it actually is, and brighter than it's going to look in your on your computer. So you want to take that into account. These are the settings, the camera settings that I've used in the past, both for full moons, but also during eclipses. And so you could also start, I usually start from these settings and see what it looks like, and then go from there. Oftentimes there's a lot of variables that can affect what the eventual picture will look like. And that's just what's in the atmosphere. Is there haze? Are there thin clouds? All sorts of things like that. The equipment. My my equipment is not the same as your equipment. And so oftentimes there's a minor variation in camera settings that because of equipment. So you could use these numbers as a starting point, and you might have to adjust over, under, things like that. But definitely start. I would recommend trying to stay at one ISO setting and one f-stop setting for much of the partial phase, because what you want to do, you want to be able to change the settings as the eclipse goes on, but it helps to be able to just change one setting at a time, because if you're trying to change multiple settings, then you start to get confused. I mean, it'll also be in the middle of the night. You won't have probably not have any sleep, and so you want to keep everything as simple as possible. As the eclipse progresses and gets closer to totality, then the umbra is, as you could see, it's very fuzzy. So as the shadow gets more and more over the moon, then the part of the moon that is showing starts to darken slightly. So as you get closer to totality, you have to give the camera more and more exposure. And so in this example, I started out with a setting of ISO 800 at f5.6, and I started at 1/1000th of a second. So that's more or less an exposure for the full moon, pretty bright moon, or a pretty large moon in the sky. And as the eclipse progressed, the moon started to dim slightly, and as it got closer and closer to totality, I ended up switching to 125th second. But I just changed the shutter speed. I didn't have to change anything else. And so the camera's on a tripod, so it's pretty steady. You don't really have to worry too much about a slow shutter speed because you have that advantage of being on a tripod. And it kind of simplifies your workflow. So choose something where you could just choose settings so that you could just slow down the shutter speed as the moon gets darker and darker. It won't be real obvious that the moon is getting darker. Your eyes somewhat adapt to minor changes like that. You'll probably see it on your camera as if you're taking a series of multiple pictures, then you'll see it, and then you'll just have to make adjustments as you go along to the shutter speed. So any questions about this part of the exposure setting? Also, before you go out there, if you haven't used your camera for a while, make sure you know where all the settings are, where you know how to change the f-stop, how to change the ISO, how to change the shutter speed, so that you'll be able to do it come next Friday morning. And so as we get closer and closer to totality, you end up slowing down the shutter speed, giving your camera more and more exposure for the moon. And as you get to totality, what I did here was I knew I had to change, so I ended up making two changes. I changed the ISO from 800 to 1600, and then the shutter speed went down to 1 second. So the moon gets very dim during totality. So that's another thing to remember, is that this is another reason to use a tripod. You don't need a very big tripod. You just need a sturdy tripod so that you could take at least 1-2 second exposures, and that everything will still be sharp. And so the good thing about this setting is that it happens to match the setting of a skyline at night. And so I did very little to this picture out of my camera. I didn't really have to adjust too many things. What I did was, I think I toned down the lights on this building that were a little bit bright. Didn't touch anything on the Empire State Building. And the sky and the moon were what it looks like out of the camera. And so the great thing is it kind of matches with an urban setting, as for example, a skyline. And you can get both objects, in this case with a telephoto lens, but also you'd be able to get something with more a wide angle lens showing the skyline and the moon. So any questions more about exposures? So everybody's going to be perfect with exposures. That's good to know. A great thing that you can do is practice. Practice. That's going to make your pictures better, because you understand your camera, you understand your lens, the tripod, the pieces of equipment that you'll need to do. The good thing about a lunar eclipse is that you can practice on the actual subject. The moon is out there. The good thing is, last night was first quarter moon, so the moon's just getting bigger and bigger each night. And so you'll be able to get out there once the moon is up during the daytime. In the late afternoon, it's rising. It's rising closer and closer to sunset as we get closer and closer to full moon. But the good thing is that as long as it's dark, you go out there, the moon's going to be up there. So you'll be able to practice on the moon. You'll be able to practice focusing. You'll be able to practice exposure. And what that will do is that, especially with the exposure, you'll be able to get a setting, a set of numbers that you could start out with Friday morning. So you won't have to guess about anything. You'll be able to start out at a setting, and you'll be pretty close. Again, it depends on the atmosphere. If there's any haze, particles, thin clouds, things like that, that will definitely affect the exposure. But at least you'll have a starting point that you could start from, and then you can go from there. Another tip would be you can go out right at sunset, set up things. The moon will be up there, so as it's getting dark, you'll be able to kind of simulate what it will be like during the eclipse. But definitely practice when it gets dark. If you haven't shot very many photos, night sky type photos with your camera, with your equipment, it's totally different when it's dark. Even if you're practicing underneath a street light, it's completely different than practicing during the daytime. So you learn where the controls are on your camera, learn how to change settings, and learn how things are working, so that in the middle of the night, because you'll be out there at the earliest at 1 a.m. shooting these pictures, and at 4:45 it's still going to be dark. So it's you'll really need to have that experience of working in the dark. So if I took this chart from the timeanddate.com website, just to show a couple of the early numbers that we need. So we look at the partial eclipse and the total eclipse numbers. You don't need to shoot the entire eclipse if you don't want to. Especially if you just want to enjoy watching the whole eclipse, you could shoot a little bit of the partial. You could shoot some of the total, and then a little bit of as the partial ends the eclipse, or you could just shoot the totality if you want. If you're just going to shoot totality, it's a good idea to get wherever you're going to take the pictures before the total eclipse begins, because it's just easier it will be easier to focus on a brighter moon than it will be the darker. So if you don't need to get there right at 1:09 if you don't want to, if you're going to shoot the total eclipse, but definitely get there. Try to get to your spot at around 2 a.m. so that you have enough time to focus on the moon, make sure everything's sharp and in focus, and then it'll just be a few more minutes until the total eclipse begins. I put a couple numbers on the side there because in case you're shooting with a wide lens, there is a way to kind of plan out what focal length you're going to be using ahead of time, and then you could go to the location during the daytime or around sunset and just see if that focal length works. So at partial eclipse, it will begin at altitude of 51.8. So let's call that 52 degrees. Maximum eclipse is at about 43.6. So let's call that 44 degrees. And I'll go to this chart. Those of you that have taken the night sky photography class might recognize this chart. I have a chart that shows you the field of view in angles, in degrees, or 35 millimeter digital camera lenses, and these numbers are for the full frame cameras. Or if you have a crop sensor camera, the smaller sensor, you basically would multiply the focal length by 1.5, and then you've whatever focal length you're going to be using, and then you find that focal length on this chart to get the actual field of view. But let's start with, say you want to start, you want to shoot the entire eclipse. You want to start when the partial eclipse starts. So the moon will be 52 degrees up in the sky. And so you want a lens that will be able to take in that field of view. So the sides of these are the short side or the long side of the frame in your camera. And so if the blue rectangle is the camera sensor, 24 millimeters is the length on this side, 35 millimeters is the length on the long side. So if you're shooting a horizontal picture, you need angle of view on the short side that's going to be 52 degrees at least to get the moon plus anything on horizon, if that's what you want. So we look at our chart, and 24 millimeter takes in 53 degrees. So that would just fit, and you get the horizon, and the moon would be right at the very edge of your picture. So if you wanted to have a little bit more space with as the partial eclipse began and the top of your frame, a little bit more sky, maybe a little bit more foreground that you see from your scene, you would need something a little bit wider. So I'm suggesting around 22 millimeters would be great for a horizontal format picture as you're looking at your scene there. If you're doing a vertical picture, we sort of look at the long side field of view. So 54 degrees would be probably pretty good to get both the moon and the horizon. You might want something slightly wider, but that would get a vertical view of the start of the partial eclipse and any kind of foreground horizon that you see in your scene. If we're going just for the mid totality, moon's 44 degrees, about halfway up, and so we look on the chart. So 28 millimeters is 46, and so you have to go a little bit wider than that. So maybe about 30 millimeters to get the total eclipse. Just if you're just doing like couple shots of the total eclipse moon, and you want more of a landscape, around 30 degrees or so. And if we go on a vertical format, we're looking at the long side, 35 millimeters. So around 44 is between 40 and 50 millimeters. And so that you'll get a picture similar to what George Piottiasa, the picture that I showed you there, where the moon starts to get bigger just because the focal length is getting longer and longer. And that might work for your picture. So any questions about this part of planning for the this is just about using a wide angle lens. With the telephoto lens, you don't really need to worry too much about the foreground and a horizon, because you'll by design, the telephotos are really concentrating just on the area around them. All right, so this is actually the sort of the end of the basic part of the class tonight. I'd be willing to answer questions for after the class. I mean, if you've got questions after the class, go ahead, and if you're part of the astrophotography group, ask them on the astrophotography group, because a lot of people might have the same question that you have, and so that would be helpful. Or you could email me, stan.honda@aaa.org. And also, if you're not on the astrophotography group and you want to become part of the Google group email, go ahead and email me, and I can add you to, as long as you're a AAA member, we'll add you to that. it's a pretty lively group. There's a lot of people post a fair amount of stuff on a weekly basis. So people post pictures, they ask questions, people provide answers. So it's actually pretty lively. And again, follow AAA, follow us on AAANY_ astrophotography or AAA and follow the Instagram settings. I see there's a couple of questions here. Let's see. Ken, you're asking about the charts. Which charts are you asking about? Ken Curry?
Yes, Stan, Stan,
okay.
can you hear me? Yeah.
Yeah, go ahead.
Yeah, I was just specifically, I would love that last chart, but if any of them are available, that'd be great too.
Is that the field of view chart?
Yeah, with the different focal lengths.
Yeah, I could send out an email with a Google Drive, and I'll just put it in the Google Drive.
Great, thank you.
And then you could take a look at that. The other charts, like the eclipse information, that's off of timeanddate.com, so you could get that pretty easy.
Sure.
And then we have a question about a group outing for the lunar eclipse. That's another thing I wanted to talk about is David Gluchowski and I have been scouting out a location, and we may have found a pretty good one on the Lower East Side of Manhattan. Let me go to the location that we're looking at. Everybody just sees the map, right? You don't see any other, like the meeting chat or anything, do you, on the screen?
The map is there.
Okay, so what we did, there's actually a really interesting place. It's called Pier 35. And it's got, you could see a little bit of this view. It's got a pretty spectacular view of the Manhattan and the Brooklyn bridges. And it's down on the, essentially on the Lower East Side. There's a very wide pier with a lot of seating area here. And then there's an area along a walkway. There's a walkway that goes all along the shore here. And there's a nice spot that has almost a area that's just above the river level that has a nice view of the bridge. And the astrophotography group will probably, I'm going to send out some details on the astrophotography group email about that location. The AAA itself, I'm not sure if they planned any kind of general club outing, but this is where David and I are going to be, and we'll send out send out more information about that particular location. So it's Pier 35, and just to put that in more relation, here's East Broadway, there's Chinatown, there's a F train stop there on East Broadway. There also is a garage. There's a building called 1 Manhattan Square, and there is a parking garage within that building, which is pretty close to the entrance to Pier 35. And so it seems like a pretty good location that will have a nice view of these bridges for a really good foreground subject matter. And the moon is definitely above the bridges throughout the entire eclipse. And so Mark asks, on the picture on the last slide, how did you meter the shot? Well, I did. Let's see. Oops, sorry, Mark. Are you talking about this one, Mark?
No, that one. Did you use spot metering there? Did you focus on the moon or on the buildings, or did you use something more like average or wider?
Well, are you talking about focusing or exposure?
Exposure.
Okay, exposure. No, I use let me back up. So remember I was saying I have these various settings that I use that I've used in past eclipses. And so when it got to total, I knew that this was a pretty rough estimate of what how I could do it. And it turned out to be a very good estimate, because that's the exposure that I used for this picture. And so I knew that from experience that would be pretty close. And as it turned out, it was. I mean, the moon next Friday, it might be brighter, it might be darker during totality. You just have to adjust for that. You could use a spot meter if you're using a long telephoto lens. You could also do that, and you'll probably get a pretty good reading. This would be a good set of numbers to start out with, though, if you were going to do that, and then you could adjust from there, depending on what you see on the back of your camera as you're shooting pictures. You've got a whole hour plus during the total phase, so it's something that you don't need to rush through unless you want to. But it's kind of a good. To me, this is a good starting numbers that I'll work with, and then I'll just adjust depending on what it looks like. And let's see.
Thanks.
Sure. Trying to look for some questions. Oh, okay. So Eden says, I'm going to Hawaii in 2 weeks. Well, that sounds pretty nice. So let's take a look at Hawaii. Again, you could do this at home. You could go to timeanddate.com, and I would suggest that. Eden, where in Hawaii will you be?
Hi. So I'm going to be in Honolulu,
Okay.
but I also wanted to go to the 2 national parks there.
In Honolulu?
No, the Volcanoes National Park and Kilauea.
Kilauea is one of the volcanoes in the national park.
Sorry, I don't know the name of the other national park.
Are you thinking of Haleakala on Maui?
Yes, that's it. Yeah.
Okay, those would be 2 amazing places to see a total eclipse if you're gonna see one.
Oh,
But-
well, I'll be going after that, but I just
Oh.
wanted to get general I think you should be able to get photos of like the Milky Way, right?
Yeah, this is really about the lunar eclipse. Send me an email if you're interested in locations, because if you're going to be there during the eclipse, I could help you. But otherwise, just send me an email, and I could give you ideas about where to shoot in the parks.
All right, thanks very much.
Okay, sure. So there's a question about trying to shoot photos of the moon using a smartphone, and I have not. So apparently the night settings have become much better with the phones now, and so I think you could try it. It's essentially using a wide angle lens to get get landscape, get a cityscape, and the moon. It actually might be okay during the totality. During the partial phase, you'll probably get a lot of overexposed moons, and that's probably not what you want. During the total phase, since
you can on the iPhone, for example, you can make adjustments to all the settings. You just have to learn how to do it. And the other challenge is if you're going to do it handheld, that's a real problem.
Yeah, because it's gonna, no matter what the settings are, it's during the totality, it's gonna be a relatively slow exposure. There's no getting around that. And so I would actually suggest to watch the partial phase and just watch it, and then during totality try to take some pictures, because the moon will be much darker, and it'll be closer to the exposure for the skyline or the city lights, and so you actually might get a halfway decent picture. That's sort of a good idea. I may actually try that myself, because the difference between the brightness of the moon and the skyline won't be that big. Now, it'll be different than during a full moon or even like a first quarter. The moon is very bright compared to the skyline, and so that's why your pictures really don't turn out usually if you're you're taking with a smartphone. Let's see. So, Lucia, okay, so David Gutowski uses Planet Pro, and it does work with the bridges. It's a very, very interesting scene, and you're welcome to join us. We're hoping to get a small group of people. That'd be nice. And there's, like I said, there's both the path and the pier they're pretty wide, very well constructed, lots of seating areas, mostly big steps, but some raised platforms, and the view is pretty spectacular of the bridges, and then looking over into Brooklyn. So that's pretty nice.
So that's Pier 36, you say, or 35? I forget.
It's called Pier 35, George.
35. Okay.
Yeah, let me go to the map again. Here's the pier again, and you get a view sort of like this of the Manhattan Bridge, Brooklyn Bridge underneath it, Brooklyn off to the left of the Manhattan Bridge. So a pretty nice view. So if you want to stick around, I'm going to talk a little bit about doing the time-lapse composites next. If you're just interested in the eclipse, like single shots, things like that, thanks for coming. But everybody's welcome to stick around. I'll just continue for a few more minutes on the presentation. And let me find the slides. Okay, so I'll talk about composites, both telephoto on the right side, more wide angle on the left side. These are both, the one on the left side is from the 2015 total eclipse. One on the wider shot is from the November 2022 eclipse over Manhattan. There's a few things to remember, and not much more to remember than with the general information that I was giving you. The main things are the top two. You need a sequence of images at regular intervals. That'll just help you in the processing after the eclipse happens. I suggest shooting pictures if you're gonna do any kind of composite, especially a wide angle one. I would suggest shooting at 1 minute intervals. Set a remote timer for 1 minute. A lot of cameras, a lot of the especially the mirrorless cameras, the Sony, pretty much all the Sony A7 cameras, the Canon R cameras, and I think the Nikon Z cameras have built-in interval timers that you could set. So that's built into the camera. Or if you've got a wireless remote that you used previously with a timer, I would suggest 1 minute intervals, because that way, if there's occasional clouds, which you can never predict, that come over the moon, then later on you could kind of choose the interval that you want, so you'll avoid that cloud that passed over the moon. You could, what I do for a lot of the pictures is that especially for a wide angle picture, if you will look back, the wide angle picture with the skyline, that's the moon every 5 minutes. So I shot a frame every minute. Later on in the processing, I took a picture, I chose a frame that was taken every 5 minutes. And I kind of like the way it's a little bit spread out. You can see a difference with the shadow between each moon. There's a change going on. And so you could see the change as it goes through the eclipse. For the telephoto picture, I chose, again, I took a picture every minute, and I ended up picking a frame about every, I think this one was about every 12 minutes, 12 to 15 minutes, I think. And then I assembled this later. We posted 2 tutorials on the image processing, and they're called let's see, they're called Lunar Eclipse Photography, and one is about telephoto composites. So you'll be able to, I go step by step on how to put together one of these in Photoshop, and the other is called wide angle composites, and I tell you how to put together a wide angle composite in, there's actually two ways you could do the wide angle one. One is in a program called StarStax, and there's the information on where to download that. That's a free program that'll do, it's basically built for star trails. This, the idea of a star trail, it's the same as a sequence like this. You're just putting together a sequence of images, and StarStax will do that automatically. And there is a method where you could use raw files in Photoshop, and that works pretty well. And I demonstrate that on the video. So go to the AAA YouTube channel. Just look up Amateur Astronomers Association, and that shows up on YouTube. And Preston Staley just posted the tutorial videos today, so they should be at the top of the list. And I didn't want to go into a lot of details about the processing tonight, but if you're interested in either telephoto or wide angle and the processing, go to the YouTube channel. So again, you'll need a wireless or wired remote interval timer to trigger the camera, or the internal timer in the camera if you've got one. Again, you'll need to adjust exposure setting leading up to totality. This is where if you're initially starting out and you keep your ISO and the f-stop the same, all you need to change is the shutter speed. So you're just changing one setting, minimizes the time that you might be moving the camera between exposures, and it just simplifies your life. And again, you'll need to also adjust the camera during the total phase for making it longer. And there's where you could kind of set it up. You could set it, check the exposure. You'll have like over an hour during totality, so you'll be able to check the exposure, see if it looks like what you want it to, and you could make some adjustments there. And I would also check the focus every 20 or 30 minutes. Just make sure if you're between exposures, check the last frame. Is it in focus? If it's not in focus, you'll have to interrupt the intervals and refocus your camera. But if you've got it on the manual focus setting from the beginning, and you tape down the focus ring of your lens, it shouldn't change during the evening, during about 3 hours and 40 minutes of the eclipse. A couple more things with the telephoto. You'll need to track, at least follow the moon. You don't need to track it accurately. If you've got a telescope mount, that would be good. Manually, I use the Benro geared head, and that works perfectly well. You have to pay attention to it. About with a 500 or a 600 millimeter lens, I can get about seven to 8 frames as the moon goes across, moves across the frame. It's like if you're observing through a telescope and you don't have a tracking mount, you'll see the moon or the stars basically moving through your eyepiece. Same thing there. And so about every 7 or 8 minutes, you'll just have to move the lens to compensate for the movement of the moon. And so that's not too bad. With the wide angle, you'll need to select the foreground scene before the eclipse starts, because everything in it will need to be set once the partial eclipse starts. Select a spot where the tripod won't be disturbed, because you won't be able to move the tripod during the eclipse if you want that effect of the sequence of the moon moving through the sky. And I think for most locations that you'll set up, I don't think this would be too much of a problem. Again, take a look at the AAA YouTube channel for the image processing tutorials, and the recording for tonight I'll also post on the YouTube channel as well, so you'll be able to find all 3 videos there after tonight. You could definitely find the 2 processing ones tonight, and tomorrow at some point I'll post the class video. All right, and again, if you got questions, if you're part of the AAA, the astrophotography group, send me something through there, or send me a question through the my AAA email, stan.honda@aaa.org. And if you got some good eclipse pictures from next Friday, tag us at AAANY _ astrophotography on Instagram, and Chirag will make sure to try to share your picture on the club Instagram. So any questions before we wrap it up?
What is plan B, Stan, if the clouds
No plan B, George.
no plan B?
I guess I suppose I should be looking at a map and just seeing. I mean, today's long range forecast for Friday was good. Friday said clear. So I'm sorry, not Friday. Thursday said clear.
Thursday.
So I'm hoping that continues into Friday. Although Thursday night it said cloudy, so that could be a problem depending on when the clouds. I guess we'll be looking at Ventusky and all sorts of cloud apps to see if we'll be okay that early morning hours. What about you, George? You have a plan A or plan B?
And right now, actually, I'm thinking of staying home for plan A, and plan B, I don't know. I'm also watching the cloud coverage over, let's say, Western Pennsylvania. It looks like Western Pennsylvania right today. Today's forecast, Western Pennsylvania was nicer than this area. But also maybe south, I don't know, Virginia.
Yeah. I mean, there's a lot of places within driving distance, but again, as long as the clouds cooperate, as long as the sky is clear, if you could see the moon from where you live, you could see the eclipse. It's you don't need to be in a specific path like a total solar eclipse. So if the weather forecast looks good, you might not have to travel far to actually see the eclipse.
Right.
All right, everybody, thanks a lot for coming, and we'll send out an email just letting you know about the recording being posted on the YouTube channel. And again, if you've got any questions, send an email, and I'll try to answer them as soon as I can.